Hey guys, welcome back to another IGCSE Add Math topical question video. Today we'll be covering proofs in trigonometry for the 2024 papers. So let's get started. So basically for all parts of this video, we will be just proving the question. And I'll be going to walk through you guys the steps of how to prove and like maybe any tips. So for this question, you have to prove that the left-hand side equals to the right-hand side. Usually when you get this kind of question where there's an expansion, it's easier to start from the expansion, so start from the left-hand side. So first we can expand this first. So we get 4 tan squared theta minus secant squared theta. And then you can actually use this equation, the trigo identity. You can change the secant squared to 1 plus tan squared theta. Once you simplify it, you will get the answer. So left hand side is equal to right hand side. Or actually you can conclude left hand side is equal to right hand side. So the proof for this one is shown. Okay, so for this kind of question, you have to start from tan theta plus cot theta and show that it's equal to secant cosecant theta. So usually for proofs, it's easier to change the tan theta into sine and cos. So we can do that right now. So tan theta is equal to sine theta over cos theta. And then cot theta is actually just 1 over tan theta. So it's the inverse of tan theta. So it's cos theta over sine theta. And now you will see that you have two fractions. So you can make the denominator the same. So cos theta sine theta will be the denominator. And then you multiply sine theta to sine theta. So you get sine squared theta. And you multiply cos theta with cos theta. Okay, so you know from this identity that you can change the numerator into 1. So you get this. And this is actually just 1 over cos theta times 1 over sine theta. And 1 over cos theta is secant theta, and 1 over sine theta is cosecant theta. So this is the question proven. Okay, so for this question, we have to start from the left-hand side. And since there's actually two cotangent in the left-hand side, you have to change it into cosecant and not cosecant. You have to change it into cos and sine to make it easier. So we can use this identity. And so we can change the numerator of the left-hand side into cosecant. Okay, so cosecant is equal to 1 over sine squared theta. And this is divided by cosecant squared theta. And cosecant squared theta is the inverse of tan theta. And tan theta is equal to sine over cos. So cot squared theta is equal to 1 over tan squared theta, which is equal to cos square theta over sine square theta. So we can write cos square theta over sine square theta here. And this will give you sine square theta over sine square theta cos square theta. And you can cancel out sine square theta to get 1 over cos square theta, which is therefore equal to secant square theta. So this is equal to the right hand side. And you can conclude left hand side is equal to right hand side, and this question is proven. Okay, so this question isn't really a proof question, but you have to rewrite the equation in the question using like trigo identity. So I'll just like walk through it. So basically you have this fraction here, and in the numerator you have two parts of the equation, and you can actually just split the numerator, so you'll get 1 over cos square x plus 2 sine square x over cos square x. And you can like simplify it. So 1 over cos square x is equal to secant square x, and this is actually just 2 tan square x. Because if you take the 2 out, it's sine square x over cos square x, which is tan square x. And yeah. And then you can use the identity 1 plus tan square x is equal to secant square x to simplify secant square x. So you'll replace it with 1 plus tan square x plus 2 tan square x. And this will give you 3 tan square x plus 1. And this is in the form that the question wants. Okay, so for this question, you have to show that the left-hand side, which is this part, is equal to this part. So to rewrite this, we have to change the cosecant and cotangent into cos and sine. And so cosecant x can be changed into 1 over sine x, and then cotangent x is cos x over sine x. And then we can just simplify this, sine x over sine x over cos x. So we can cancel out the sine x in the brackets to get 1 over cos x. This will give you sine cube x over cos x. And actually, you can just take one of the sine x out from the sine cube x. So this will give you sine square x and sine x over cos x, which will then give you sine square x over sine square x tan x. So yeah. Okay, so for this question, you have to show that this part is equal to this part. And what I did is that I expanded tan x plus secant x, and then now I'm going to change the secant square x into 1 plus tan square x using the identity. So this will give us 2 tan square x plus 2 tan x secant x plus 1. Okay, now we have tan x and secant x in the equation, and we can change both of these into sine and cos. So 2 tan square x will give 2 sine square x over cos square x plus 1 plus 2 sine x cos x. And secant x is equal to 1 over cos x. And what we can do is make cos square x the denominator in for all of it. So cos square x, and we will have 2 sine square x on top, and multiply the 1 by cos square x, and we will have 2 sine x. Okay, since the question only wants it in terms of sine x, we change all the cos square x into sine square x. So 2 sine square x plus 1 minus sine square x plus 2 sine x over 1 minus sine square x. So we collect the terms. Okay, so the terms above is actually just a quadratic, and then we can factorize both the numerator and the denominator actually. So the numerator will be sine x plus 1 multiplied by the same thing. The denominator will be 1 minus sine x plus multiplied by 1 plus sine x. And then we can cancel out this and this to give 1 plus sine x and 1 minus sine x. So this is proven.